So we have a two-part lesson today. The first part is on zero and negative exponents, and so we're going to cover two different foldables. So the first one, and this is going to be our rule for anything to the power of zero. So anything to the power of zero equals to 1. Okay, anything to the power of 0 equals to 1. So any base, and the base could also be y or x or whatever, or 0. I mean, not 0, but if you have a letter like a to the 0 power, that equals to 1. X to the 0 power, that equals to 1. Okay, a number to the 0 power, like 7, equals to 1. -5, the quantity -5, because that's all grouped together, to the 0 power equals 1. Even a decimal to the 0 power equals to 1. So I'm going to go over why this is true, because you do need to know mathematically why it's correct, not just, oh, I need to memorize that anything to the 0 power is 1. A lot of times if you know why that's true, then you will memorize or remember why that is, the correct answer. So let's just think about this. Let's just take a base 10. Okay, that number is the base. So let's say I say 10 to the 4th power. Okay, 10 to the 4th power is going to give us 10,000, correct? 10 to the 3rd power will give us 1,000. Is that true? All right, 10 to the 2nd power is what? 100. So technically, if I were looking at just 10,000, 1,000, 100, each time I'm dividing by the base, which is 10. Do we agree? Because to go from one, power down, to the next, I'm really dividing by the base, which is base 10 in this case. So 10 to the 1st power is going to give me what? 10. Very good. So if I divide by 10 again, what is 10 divided by 10? There you go. So every single time you're dividing the number into itself, you really end up with that. So even if I had started out with, let's say, base 5. Okay, hold on one second. Let me go back to my... So let's say I did base 5, and I said 5 to the 3rd power is 125. So now I'm going to divide by 5. So 5 to the 2nd power is what? 25. So when I divide by 5, 5 to the 1st power is what? 5. So when I divide by 5, and see how once you get to this point right here, you're always dividing the base into itself, and so it's going to equal to 1. Okay, I want you to be able to see that, because I don't want anyone to ever tell me that anything to the 0 power is 0, because that's usually the common answer I'll get sometimes. So now you should know, once you get to 0, you are dividing the number into itself. Okay, and we know a number divided into itself, or even a variable divided by its, into itself, it equals to 1 whole. It doesn't matter. Okay, so if I continue doing this pattern, and I get to the negative exponents, now it turns to a fraction. Okay, so that's why you see once we start doing negative exponents in this particular lesson, it then becomes a fraction. And notice that, there's like an invisible 1 here. The exponent becomes positive. Okay, all right, so let's take a look. Let's go back to our foldable. So now this is the negative exponent, and we just really kind of seen this come to light of just in my example. When you have a negative exponent, when you have a base raised to a negative power, you end up with taking the reciprocal of it. So I end up with 1 over a to the positive n. And notice how this n right here becomes positive. And that's what you want to happen, because you cannot have negative exponents in your final answer. Okay, so we always have to eliminate negative exponents. So 3 to the negative 4th power is going to be 1 over 3 to the positive 4, which is 1 over 81. Okay, and I think you guys already have this written in your foldable, correct? All right, so if I do this one, and notice that you keep the parentheses around it, so now you're actually also raising the negative to the power, so that's 1 over 49. Okay, so let's keep moving. So now we're going to practice some problems. So I cannot leave my answer as 7 to the negative second. So I'm going to rewrite it as 1 over. So we're going to take the reciprocal. So this will be 1 over 7 to the positive 2. Because remember, this becomes positive when you take the reciprocal of it. All right, just the exponent, because this rule only applies to exponents. It doesn't apply to the base. Okay, what is the base here? 7. Very good. So now you will tell me that 7 times 7 is 49. So don't leave it as 1 over 7 to the second. You have to say 7 squared is 49. Okay. All right, the next one. Well, we just went over this. Well, what's 13 divided by 13? Because that's basically where you are when you got correct 1. Because when you're at 0 power, that means you're dividing the base into itself. All right, number 3. Now, this one is different from the first one we did because the negative exponent is actually in the denominator, correct? So if I take the reciprocal of it, it's going to end up where? In the numerator. Very good. Because what you're doing is taking the reciprocal. So when this rule over here says a to the negative n equals 1 over that, they took the reciprocal in order to make it a positive. So if this is starting in the denominator, when I take the reciprocal, it's going to end up in the numerator. Oh, sorry. That should be a positive too. Okay? Because that's the whole purpose of taking the reciprocal, so the exponent will become positive. You can't leave negative exponents in your final answer. That's the whole goal. So, since this is actually in parentheses, I am squaring the negative. So a negative 4 times a negative 4 is a positive 16. Are we okay with that example? Okay. All right, so now this one is really started out in the numerator because this is like an invisible 1 underneath here. So that's in the numerator. So when I take the reciprocal, it's going to be 1 over n to the positive 1. Now, we don't have to write positive 1 as an exponent. Actually, I prefer that you not. So just leave it as 1 over 9. Okay, you don't have to say 1 over 9 to the positive 1. Okay. All right, next one. Now, this one is a little tricky because the negative is not in parentheses. So really, this is only pertaining to the 5. So 5 to the 0 power is what? 1, but that negative is still there. Okay? This, now, if it had been written this way, then the answer would have been 1 because you're also raising the negative 1 to the 0 power that's in front. So be very careful with that type of problem. If it's not in parentheses, you're only raising the 5 to the 0 power and not the negative. Okay, so these are two different problems right here. All right, next one. So this is like an invisible 1 here. So when I take the reciprocal of it, I'm going to have this. 1 over 2 to the positive 5. And 2 to the 5th power is what, 32? So you got to say 1 over 32 as the final answer. All right, number 7. Okay, see how all of this is in parentheses? So when I take the reciprocal, I'm going to have 1 over in parentheses. Now keep in mind, this negative stays. Okay, this one changes to a positive. Because again, this rule is only for exponents. It's not for the base. Okay, and that's the common mistake that students make. They'll change the negative 4 to a positive 4. The rule only applies to the exponent. Okay, like this one. This is a case in point right here. Okay, so here I have negative 4 to the negative second. right? So, yes, I am going to write it as 1 over -4 to the positive second. Now, be very careful with this because -4 to the positive second is actually -16. Why? Because, again, you're only raising this to the power of 2, not the negative, because it's not in parentheses. And that's very important. I know I keep saying this, guys, but that's very important, okay? Because that's usually the mistake that students make, and they'll say this answer is a positive 16, and it's negative, okay? All right, let's take a look at this one. Well, I want you to understand as well that each number and each letter, variable that is, has an exponent, like that 7 to the first power, x to the first power, y to the 0 power. We just don't write exponents that are +1, but you have to remember, it's understood, they are there. So anything to the 0 power is 1, so technically that's just times 1. Well, what's 7x times 1? 7x. You don't write the y to the 0 power because that equals to 1, and you're just multiplying it all together. Okay. All right, let's take a look at this one. Now notice how I've already moved the variable or taken the reciprocal, which means it just moves to the top because it started out at the bottom. So when I take the reciprocal, it just flips to the top. Are we okay with that? Okay. If it starts at the top and it's negative, you move it to the bottom. If it starts at the bottom and is negative, it goes to the top to become positive. Okay. All right, now let's take a look at this one before we go through the answer here. Notice again, I told you that every number and every variable has an exponent. So this 5 really has an exponent of 1. It's positive. I don't need to bother that. Anything that's positive stays where it is. Okay, so that 5 will stay in the numerator. The d to the -4 will come down to the denominator, so it will become +4. So you don't think the 5 and the d are attached and the whole thing is to the -4. The only thing that's raised to the -4 is the variable. Same type of setup. You're only going to bother with this. Okay, because we already know n to the 0 power is 1. We're going to move the m to the -7 into the denominator, so that will become +7. Are we okay with that one? Okay, thank you, Calvin. All right. Okay, so see how I did this problem? I left the f to the 5th where it is, because why? Why did I leave this here? Because it's what? Positive, right? If it's positive, leave it alone. I'm going to take the e to the -3rd. I'm going to put that into the denominator because I have to take the reciprocal to make that positive. So anything that's positive, guys, leave it where it is. And just make sure you understand that each number and letter has its own exponent. All right, let's take a look at this one. See how I left the 3 where it is? I left the a to the 1st where it is. Okay, I left the 5c in its place. The only thing I had to move down to the bottom was this negative exponent. Okay, everything else stays. Everything else stays. All right, let's look at this one. Notice I just said anything to the 0 power is 1, so you just don't even see that because 9 times 1 is just 9. The y to the -7 has to be moved to the bottom to make it positive. And the z to the 3rd, take the reciprocal, move it to the top, so it'll become z to the +3. All right, next one. All right, so let me walk through this one together. See where the negative exponents are, and then sometimes what you want to do is maybe just kind of circle the ones that are negative because you don't really need to bother the other. So like the m to the 5th will stay where it is. I'm going to put the 2 to the third down here so it'll be positive. And so this will be positive. And now I can say that 2 to the third power, 2 times 2 is 4, 4 times 2 is what? 8. So you do want to actually say that 2 to the third power is 8. Okay, you want to leave it as, you don't want to leave it as 2 to the third. All right, was that the last one on that one? Okay. All right, so let's move on to your other foldable, which is the scientific notation one. So go ahead and fold it. You won't have, when you fold it, you're going to have just what is scientific notation, adding, subtracting, multiplying, and dividing. Okay, these tabs will actually be inside of the problem, so you're not going to see it on the outside. So you should just have 3 tabs. Okay, you should have what is the scientific notation, adding, subtracting, multiplying, and dividing. Spirit 8. Okay. All right, so let's first go over what scientific notation is. It's just a method of writing very large or very small numbers by using powers of 10. So I only want you to write that sentence. You don't need to write what's at the bottom, okay? But I do want you to see what's at the bottom. The first number has to be at least 1 but less than 10, and we always use base 10. And I do want you guys to make sure you're using the X for multiplication for scientific notation and not a dot. So what do we use? An X. All right, so we're going to be using the X and base 10. Okay, that's how we write a number in scientific notation. So the only 2 numbers you'll have to figure out will be the exponent and this number here in front of the time symbol. So it's just a method of writing very large or very small numbers by using powers of 10. All right, so what you're going to do is you're going to go to your calculators, okay? And I'm going to clear all of this out. So when you go to your calculator, okay, pay attention because you're going to, and again, this is all going to be a calculator exercise. So we're going to put our calculators in scientific notation mode. So we're going to press the button right here that says mode. Okay, now yours could be flashing on normal when you do that or not. Okay, in a minute we're going to have it flashing on SCI. So we're going to cursor over. If yours is not already there, you want it flashing on SCI. So just arrow over one, hit mode and arrow over. And now how many people are flashing on SCI? Great, and now hit enter. So what you have just done is you have placed your calculator in scientific notation mode, so it knows how to write a number in scientific notation. It knows the first number has to be at least 1, okay? And then I'm going to show you how you read it from the calculator, because it doesn't look the same like when you write it from the calculator, so you're going to have to really pay attention and make sure you know how to interpret it. So let's just clear out this screen. So let's just hit second mode. That will just quit us out of it. So now that I have this calculator in scientific notation mode, I can put in any number and it can convert that number to scientific notation. So let's say I put in 0.123 and let's put a couple zeros. Okay, so let's say I want the calculator to convert this to scientific notation. So I put in 0.12300. I'm going to hit enter. And look, it tells me 1.23 e negative 1. Now, I want you to know how to write that on your paper. If you had this, you would write it as 1.23. E is the exponent. So you're going to say times 10 to the negative 1 power. Okay, isn't that cool? That's really neat. All right, so if we want to put in like 62,000. Okay, 62,000, hit enter. So if I were to read that or write it on my paper, I would write it as 6.2 times 10 to the 4th power. It's cool, isn't it? I know, it's cool. So this particular foldable one, it's just going to be a matter of practicing with, typing it in. So let's go back to our foldable. So if we go back here and let's just look. So how do you know these numbers are in scientific notation or not? Well, the decimal should be after the first number. Okay, you should obviously have times some base 10. This one you would say yes. So everybody put yes. Okay, is number 2 in scientific notation? No, because the decimal is not after the first number. So now you can either do it yourself or you can have the calculator do this. So you can type it in as 0.56 times 10 to the 8th, hit enter. Okay, so let's try that. So I'm going to put in 0.56 times 10. And then to raise it to the 8th power, you hit the little caret key here and then put in 8. Now, when I hit enter, since my calculator is in scientific mode, now I have it in scientific notation. It's going to be 5.6 times 10 to the 7th power, and that's what you would write on your foldable. Okay, so I'm not going to do all of these because that's something you can just do on your own. Like I said, it's just a good practice for you. So I'm going to move along in your foldable to adding and subtracting. So I want you to go through your foldable and look for this problem with adding and subtracting. This one right here. So find this problem right here. Okay, it is in your foldable. Okay, just look for it. And we're going to type this in exactly like we see it, even with the parentheses. So above numbers 7 and 8, I believe, are the parentheses. Is that correct on your calculator? Okay, look on your calculator. Where are the parentheses located? Above which numbers? 8 and 9. Okay, so above 8 and 9, you're going to do an open parenthesis first and type that in, plus open parenthesis, close. All right, so actually we didn't have 1, so go to number 2. You should have this one, 8.36 times 10 to the negative 3rd minus, and again, type it in exactly like you see it. And then I'm going to ask someone for the answer in a second. Okay, so right above numbers 8 and 9, you should see the open and close parentheses. So when someone has an answer, if you could share that answer out, please. Yes. If you did not get this answer, I would suggest that you just type it in again. Because, we're just typing it in, okay? And hitting enter. So let's do number 4. We're going to do one more of the addition. So we did a subtraction. Let's do an addition. And then we'll do one multiplication and one division. Okay, so type that in. When someone has an answer to share, please let me know. All right, so check your answer for that one. Okay. All right, so here's our multiplication problem. 3.2 times 10 to the 5th in parentheses. Parentheses again, 1.75 times 10 to the 3rd. Okay, see what you get for that one. We're just going to do one of each operation because all you're doing is typing them in. All right, raise your hand if you got 5.6 times 10 to the 8th power. All right, very good. If you didn't, just type it in again. Okay, just type it in again. All right, we're going to move to a division. So let's look at example 2 under division. Now, to type this into the calculator, notice that they did not put parentheses on these, but guess what? You still have to use parentheses, okay? So please, when you put this in, do your parentheses, hit your division bar, and then do your parentheses again. You will get an answer if you don't use them, but it's not going to be the right answer. So it has to be grouped in parentheses. So keep that in mind. So even in your textbook, they're not going to use parentheses. Okay, you have to know you still have to use those parentheses for division. So go ahead and see what you get for that one, and that'll be the last one that we do. Okay, so once you're done, I'm going to just put the answer up. Make sure you check to see if you were able to get 1.6 times 10 to the fourth power. Raise your hand if you did. Great.